Welcome back, and in the last few chapters we have introduced the core components of the analytics, the model, which is the AI export. We also talk about the data set in our chapter 2, which is the study material for the export, and in the third chapter we talk about utilities. These were the helpful tools for working with models and data. So now when we want to train our AI export on our specific study material, or perhaps use it to make predictions, there are many dials and switches we need to set. So how long should it train? How many pictures should it look at simultaneously? And how confident does it need to be to say it has found something? And these are all controlled by configuration. Basically, it helps to set to customize model training and behavior. So these are also stored in YAML files, which we discuss on our chapter 2. Helps to define hyperparameters. These are the learning rate, batch size, which are very popular while we run the models, which are very useful parameters. And also helps to control the task specific settings, whether we are going to do detection tasks, classification, or segmentation. These are controlled. So think of a configuration as the complete set of instruction, or it is a rule book that tells analytics exactly how to perform a specific task, like training a model or making the predictions. It bundles together all the settings and hyperparameters needed for a job. So why is it important? Basically for three main reasons. One is control. So for example, you need to control things like training duration, which is in the other word known as epochs. So how much you are training, and how much data is processed at once, which is also known as a batch size. So how many images you are giving at a time. Another is the sensitivity of the prediction, which is the confidence threshold, for example, for this accuracy thing. Next is organization. So for example, we have to keep all the settings in one place to make things accessible as well as easier, and it will be standard. That helps to make our experiment more reproducible and easier to manage. For example, when I'm visiting our GitHub repository and trying to access this YOLO or other many important tools, then if that is not organized, then it is very difficult for me to reproduce it. So therefore, it is very good for having the configuration, proper configuration. And next is the flexibility. So for example, to change certain settings, it is very easy from this configuration file. You can easily change settings for different experiments or different tasks without changing the core code. So if you are not going to switch in the core code, then it will be very easier for you. So you are not going to look everything, every details, but just you are tweaking one thing or two from this configuration file, and everything will work perfectly. So these are the mechanism that is provided by the configuration. And this alternatives gathers configuration settings from a few places, like default settings. So I'm sorry for the spelling. So there is a main set of default settings, like default settings are these are the main set of default settings for different tasks. So they can be found on the default.yaml file within the library's structure. Next are the configuration file, which can be provided, which are all our own settings, like the data.yaml, which we talk in our dataset chapter, is one example. So you can also have YAML files that configure training settings and the model architecture. So basically, there can be many variation. And another is arguments. So you can pass settings directly as arguments when you call methods, like we have called model.train as well as model.predict. So we can pass the arguments within these functions, and from that also the configuration setting can be accessed. And arguments provide directly override the settings from the default files or other configuration files. So these configuration systems bring all these sources together. All right. So let's talk about while you might not call it directly very often as a beginner, the function that does the heavy lifting behind the scenes is get config. This is a important function which works under the hood. Okay, so for example, it helps to load the base default settings like from the alt analytics config default YAML, and also helps to load other tax specific default settings for different tags which you have customized. Additionally, it loads settings from the YAML files that you specify like your data.yaml, and merge all these settings, gives the priority to settings found in the later sources. Like when you override that, then the later one it will be using that sections, the override one, and later it will return the complete configuration object ready for the task use. So that it will be the block, and it will make a rule, different rule will be made by this function, and it will be passed for out any model to use. So this ensures that when you call this a model.train or something like that, the training process has all the necessary settings assembled correctly. So so putting these configurations to work, we can have a certain example. So let's revisit the training process from the chapter 2. Okay, we have this model YOLO ph and the pt file to train from this class. And when you train a model, you need to specify many things like which data set to use, and how many times to go through that data set, which is also called epochs, and how many images per step or batch. So you can have the epochs, so you can have the batch, you can also have the this configuration file, and also image size. So via file you can load as well by using this data.yaml, and the via arguments also you can pass directly epochs, and this batch you can pass this, and these arguments, as I mentioned earlier, override any default values for the epochs or the image size and the batch that might exist or are set differently in other loaded configuration files. So this section basically provides the information about where to find this data set specific settings. And this model.train method, it internally uses this get cfg, that function mechanism, to collect all the relevant settings like defaults and settings from this our ml file, and also from the provided arguments. If we provide the arguments, this epochs, image size, and the batch, it will see everything. So into a single configuration it will be merged, and that guides the entire training process. So next we will be talking about for the other tasks. So configuration, it is not just for the training. Okay, so we in our first chapter in our model, we talk about how we talk about not only for the not only for our training, but for the validation and the testing. Therefore this configuration can be used for the validation, prediction as well. So in the for the validation, we will be using this model dot not train model dot val validation. So and for model dot validation, and for the prediction we use model dot prediction. So this will need the settings from the data. We can have the data YAML, image size, and the batch, which is passed as the arguments, and these are the confidence threshold as well. And the prediction model is also doing the same thing, need settings like source, okay, image source, and other configurations things. So this will be over. So look here, the configuration, it will override the default confidence threshold. For example, if in the default file we have 0.25, then when we pass like this, so it will be changed or override into this 0.5 value. And the later export, there is another export which needs settings like format and ONNX and like that, which will not be discussed here. So in each case we can talk like we can override the default settings by providing arguments. So basically this get cfg process happens implicitly within this method calls to assemble this full set of instructions. So this is the how the configuration flow. So this is little complex when we compare it with our other functions like utilities. So for example, when you call a method like model.train, how does it work? Here the diagram shows that your call to model.train triggers the get config. So when you are configuring for the train mode, this get config function would be get config functions will. So we have this all these files, all right. This the get config function and related configuration, these are located in our this GitHub repository, which can be found. If we look at detailedly there, we'll be not talking about these things. So but we can see how this get config will be loading the default settings, and which will be returning here. So it will be calling all things like default YAML, our data YAML file, as well as the argument file, and it will be like first accessing default YAML, then our data YAML file, and later method arguments to override the sections. And all these after this, it will merge all the settings like arguments, override files, and the file override defaults, and return to the final config object. And this config object, which will be only then used for the training. So and later, after processing, the result will be shown. So in this chapter, we learned that configuration is the system or analytics uses to manage all the settings and hyperparameters. Later we'll be talking about this chapter 5, but in this chapter we talk about how hyperparameters and all the settings for its various tasks like training, validation, and even and the prediction or the testing are managed by this configuration. And this configuration, it basically acts like a rule book, gathering instruction from default values, even the configuration files, and also the direct arguments which we provide when calling the methods. The core get config mechanism works behind the scenes to assemble these settings into a single source of truth for this all the tasks. So understanding the configuration empowers us to control exactly how our models behave, us to fine tune training, adjust the prediction sensitivity, and this manage the result shaping. So now that we understand how settings are managed, we are ready to dive into the components that use these configurations to perform specific actions. So we'll start with the predictor in the next chapter. Thank you.